Howdy, aggs! I'm here to explain Lewis dot structures and everything associated with them. So first, what exactly is a Lewis dot structure? Well, it's supposed to explain how the elements are associated with the rest of the elements. So let's take CO2, for example. CO2, whenever written out like this, looks like that. But what we want to do is we want to try and write them out. So we know that C is the central bond, and we have two oxygens. Carbon, oxygen, oxygen. So first what we need to do is we need to calculate the total amount of valence electrons. And you may be asking yourself, what exactly is the valence electron? Well, whenever you look at a periodic table, they are categorized into different rows and columns, and they have 1, 2, 3, 4, 5, 6, 7, 8. Wait, yeah. So they have these columns that dictate how many valence electrons they have. Doesn't matter what row they are in, it only matters what column they have. So it's sorted by 1, 2, you skip a few, 3, 4, 5, 6, 7, 8. And each element, aside from one, which we'll get to later, needs to have 8 total electrons. Now how they do that, whenever they're bonding. Now how they do that is they do that by sharing electrons and having lone pairs. Lone pairs, shared pairs, they need to have what's called an octet, which is the 8 electrons, valence electrons. So oxygen has 6 valence electrons. It's in this row. So we get 6 times 2, because there's 2 oxygens, plus however many carbon valence electrons there are. There's 5 carbon valence electrons, so 5. We add that up, and we get 17. So what do we do now? Well, we now try to associate those valence electrons. Now we have 17. It's not enough for all of them to just have 8 lone pairs on their own. They have to share. So how do we do that? Well, we dictate that by this. This line shows that they share 2 electrons. So this is basically like 2. So our total goes down to 15 available. So now we just share a few more. Share with carbon, oxygen, both sides. And we share again to make sure that carbon has all 8. Now we got to feed oxygen. So we've spent 2, 4, 6, 8 of these. And we have how many left? 9! So we give oxygen that. 1, 2, 3, 4, 5, 6. Stop! What for? Oh, I didn't explain the dots yet. So the dots represent lone pairs, and each dot represents an electron. So that's what I'm doing here. Now, you may be asking yourself, Tristan, what the hell is going on? This one has 10 valence electrons, not 8, and that's because you're smart. So we can rewrite this and put boop, 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 boop. See? I'm screwing up all over the place. And now we write 2 more over here. Boop, 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 boop. Now let's count up however many we have. 1, 2, 3, 4, 6, 8, 10, 12, 13, 14, 15, 16. That's odd. What are we missing? I screwed up. And that's because carbon has 6 valence electrons. Whomp whomp. I am so sorry. 18 total. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. So we notice that even though all of them have 8, that we only have 16 total connected, right? Well, that means that if our total is 18 and we have 16 connected, what we can do is we can remove one of these double pairs. So that means we're down to 14. And from there, we move this around. 1, 2, 1, 2, 1, 2. Now we have 16 again. What we do from there is we just add 2 dots here, and voila! We have 18 valence electrons for this configuration. Woo! Now, there are some terms that are given to double pairs like this. That would be what's called a pi bond. And there's also sigma bonds and so many other things that other people will cover. Alright, I'm going to erase this. The last thing we're going to talk about is hydrogen bonding. Now let's say we have a little something you might have heard of called H2O. H2O is water. I mean, come on guys. Now, you write out oxygen, write out your hydrogens. Oxygen is central pair, or element, and now we figure out how many valence electrons are in total. So oxygen has 6, and there's 2 hydrogen, and how many valence electrons do they have? 1! That's right! So it's 2 times 1, and that gets us 8. Now you may already notice, hey, wait a second, they're supposed to have 8 in total. How are they going to share 8? That's impossible. Well, let me explain. You see, hydrogen only likes having 2 in total. So you share like that, and hydrogen's full. He's like, nah man, I'm good. And so they share. And that means we've gone through 4, and we give the last 2 to oxygen like so. And that's how we draw our Lewis dot structure for it. Thank you guys so much for following along, and I hope that you all have an amazing day. Thanks, and gig 'em!